Hi! Ako muli si Teacher Melvin ng Ilajuti Paliti Memorial School of Fisheries na bumabati sa inyong lahat ng magandang araw at welcome to Week 6 of our video recorded discussion for Grade 8 Science. Ngayong araw ay pagpapatuloy natin ang pag-aaral ng atoms. Pagkukulan natin ng pansin kung paano ba i-determine ang number ng proton, neutron, and electron ng isang atom ng kahit anong element na makikita sa modern periodic table of elements. For our most essential learning competency, we have determine the number of protons, neutrons, electrons in a particular atom. And by the end of the session, you should be able to locate the atomic number and mass number in a periodic table. Identify the subatomic particles associated with mass number. Perform simple arithmetic to determine the number of protons, neutrons, and electrons in a particular atom. And finally, for you to appreciate the use of the modern periodic table of elements. Before we continue with our discussion, please remember these important terms. The first one is atomic number. This is an experimentally determined number characteristic of a chemical element that represents the number of protons in the nucleus, which in the neutral atom equals the number of electrons outside the nucleus, and that determines the place of the element in the periodic table. Ion is an atom or groups of atoms that carries a positive or negative electric charge as a result of having lost or gained one or more electrons. An isotope is any of two or more species of atoms of a chemical element with the same atomic number and nearly identical chemical behavior, but with differing atomic mass or mass number and different physical properties. Mass number or atomic weight or atomic mass refers to the number that approximates the mass of an isotope of an element and designates the number of nucleons, which consist of protons and neutrons found in the nucleus of the atom. The modern periodic table of elements refers to the arrangement of chemical elements based on the periodic law. So far, you have learned about the three subatomic particles. We have protons, electrons, and neutrons, and how they are arranged in the currently accepted model of the atom. Among these subatomic particles, it is the number of protons that identify the atoms of an element, and that all atoms of an element contain the same number of protons in their nuclei. This number is the element's atomic number. In the next activity, you will refer to the periodic table in determining the atomic number. Notice that no two elements have the same atomic number. For you to be able to learn by doing, let's perform activity number 4. What's in a number? This is found on your book on Science 8 Learner's Material, page 203 to 205. Inaasahan na matatapos ka sa loob ng 20 minuto. Maaari mo namang ihinto o i-pause ang video habang ginagawa mo ang iyong gawain. Let's talk about it. Pag-usapan natin ang iyong activity. While doing activity 4, you were properly guided on the steps on how to determine the number of protons, electrons, and neutrons in a given isotope of an element that may be in neutral state or even as an ion. It may have been very difficult for you to accomplish the task, so let us complete the table that follows by determining the isotope, element name, number of protons, neutrons, electrons, and charge of every given atom. We are going to complete this table. Our table has 7 columns. The first column is for the isotope. Second one is for the element name, followed by the mass number, the number of proton, the number of electron, the number of neutron, and finally, the charge of the atom. The first row is done to serve as a guide for you to answer the table. Let us first take a look at isotope B-6. In writing the isotope, take note that it is composed of a letter, a dash, and a number. This is read as B-6. We have 2 blanks on the first column, meaning we are going to write the shorthand notation for the isotope of fluorine and neon. Now, how do we write the shorthand notation for the isotope of fluorine? It is now time for you to use the modern periodic table of elements that was given to you by your teacher. Try to search for the element of fluorine. Fluorine has a symbol of capital letter F. So we are going to copy the symbol of this element. The first thing that you should do is write the symbol of the element followed by a dash. Then go back to the periodic table and determine the mass number of the element. So the mass number of fluorine is 18.998. Go back to the table and write the mass number after the dash so that it will become F-18.998 or simply F-19 because we are going to round it off into a whole number. Take note that on our table, we also have a column for the mass number. So, if the mass number is identified on the column, you're just going to simply copy the mass number to the isotope. So, you are just going to simply copy the symbol for fluorine, which is F, then write the dash, and then the mass number. Same is true with the other elements. Now, let us proceed to neon. Look for neon in the modern periodic table of elements. Neon can be found at the rightmost side of the periodic table of elements, second from the top. So neon is beside fluorine and under helium. Neon has a symbol of capital N and small e, and it has a mass number of 20.180 or simply 20. So under the isotope, we are going to simply write the symbol for neon, which is capital N, small letter e, followed by the dash, and the mass number of neon, which is 20. So the isotope of neon is neon-20. And again, if the mass number of the element is indicated on the table, you're just going to simply copy. So our answer is Ne-20. So that is how to accomplish the first column. We are just going to simply copy the symbol of the element followed by the dash and then the mass number. Take note that the mass number is the number that followed after the dash. Let us proceed to the second column, which is the element name. The first missing or unknown element has a mass number of 28. It also has a symbol of capital S and small I. So, using your periodic table of elements, you are going to search for the element Si. The element Si is found under carbon and beside aluminium. This element has an atomic number of 14, and the element's name is silicon. So going back to the table, we are going to simply write the name of the element on the space for the element name. So the element's name is silicon. Now you try to answer the last two. Identify the elements that has an S and K symbols. So again, using your periodic table of elements, search for those elements. This is the element that has S for the symbol, and here is the element that has K for the symbol. And then write the names of those elements on the spaces. For the first element that has an isotope of S-32, so S is sulfur. For isotope K35, the element that has K for the symbol is potassium. So that's it on how to identify the name of the element. Let us proceed to identifying the mass number of the element. You can actually use the periodic table to identify the mass number of a given element. Take note that each box corresponds to one element, and each box has the atomic number of the element, the valence charge of the element, the symbol, the name, and the atomic mass. The atomic mass of the element is found at the bottom. So, you are just going to simply copy the mass number to our data. Let us take a look at boron. Boron has a mass number of 6. Let us check using our periodic table of elements if boron has really 6 as its atomic mass. Boron is found at the right side of the periodic table. It has a symbol B. Boron has an atomic number of 5, a symbol of letter B, and a mass number or atomic mass of 10.811. So the atomic mass of boron that should be indicated on our table should be 10.811. But why is it that in our table, boron has a mass number of 6? So, does it mean that our data is wrong? Shouldn't 11 be written as the mass number of boron and not 6? Now, it really doesn't work that way because mass number depends on the number of proton and neutron or the nuclei of the atom. So, to get the mass number of the element, you're going to add proton and neutron. So, the correct answer is still 6. Take note that we are talking here about isotope, and boron has some isotopes, meaning that it is a boron because it still has a number of proton which is 5, but it's just a little different as the number of neutron is different. That's why the mass number is not always 6, it's not always 10. So it always depends on the number of proton and the number of neutron. Also take note that in our isotope, we have indicated there the number 6, which means that is the mass number of our element. So you may simply copy the number 6, which is the mass number, to the column for the mass number. So the correct answer for the mass number of our boron isotope is still 6 and not 11. Always remember that the correct mass number of a given element or an isotope of the element will always depends on the number of protons plus the number of neutrons. So 5 plus 1 is equal to 6. That is why our correct answer is 6. Let us try chlorine with a mass number of 19. So our fluorine has 9 protons plus 10 neutrons. We get 19. So 19 is the mass number of our fluorine. Let us check for potassium. Our potassium here has a mass number of 35. It has a number of protons, which is 19, and 16 for the number of neutrons. So 19 plus 16 equals 35. So 35 is the correct mass number of potassium 35. That's all about determining the mass number. Let us proceed to determining the number of proton. Now, in determining the number of proton is simple as looking at the periodic table of elements. Okay, so in our table we have boron, and boron according to our table has 5 protons. I repeat, the number of protons is equal to the atomic number of the element. Let us try and check our periodic table of elements. Boron is found at the right side of the periodic table, and it has an atomic number of 5. So if boron has an atomic number of 5, meaning to say that it has also 5 protons. So 5 is the correct answer. Let us proceed to our next element, nitrogen, N-14. Let us use our periodic table of element to look for nitrogen. Nitrogen is also found at the right side of the periodic table, and it has an atomic number of 7. So this means that 7 is the correct answer for the number of protons of nitrogen. Always remember that the number of protons is equal to the atomic number of the element. Now try and fill up the missing data on our table under the column for the number of proton. Always remember that the number of protons is equal to the atomic number. So again, utilizing our periodic table of elements, look for neon, aluminum, silicon, and sulfur. Again, the number of protons is equal to the atomic number of that element. So the answer for neon is 10. Correct. 13 for aluminum, 14 for silicon, and 16 for sulfur. Did you get all answers correctly? Well done! That is all for the determining of the number of protons. Let us now try and determine the number of electrons. Let us look at boron. It has an electron of 5. How did we get 5? The number of electrons will depend on the charge of the atom. Our boron on this table has 0 charge. After identifying the charge of the atom, look at the number of proton. If the atom has a charge of 0, it means that the atom is in a neutral state, meaning to say that the number of proton and the number of electron is equal. That is why, if the number of proton for boron is 5 and it has a charge of 0, it means that the number of electron is also 5. Let us try nitrogen. It has 7 electrons. When you look at the charge of nitrogen, it is 0, meaning to say that it is in a neutral state. That means that the number of proton and electron of nitrogen is equal. Let us try and answer chlorine. Chlorine has a charge of -1. Negative means or denotes electron, which has a negative charge, while proton has a positive charge. If the atom has a charge of negative, it means that the electron of that atom is more than the number of proton. But by how much? Take note that after the charge or the symbol of the charge is a number. This number will tell us by how much is electron more or less than the number of proton. So we have 9 protons for fluorine and our charge is -1, meaning to say that the electron is 1 more than the number of proton. So the number that is 1 more than 9 is 10. That is why the number of electron for our fluorine is 10. Let us try and answer aluminum. Our aluminum has +3 charge. +3 charge means that it has 3 more protons than electrons. Take note that proton is positive. So what is that number on which 13 is 3 more? So what is that number on which 13 is 3 greater? So the answer is 10. 13 is 3 greater than 10. It is now your turn. Try to indicate the number of electron for sulfur and for potassium. What is your answer for sulfur? Correct. The correct answer is 16. How about potassium? Awesome. The correct answer is 18. Very good. After completing and determining the number of electrons, let us now proceed to the determination of the number of neutrons. Let us look at boron. Boron has 1 neutron. How can we determine the number of neutrons on this table? Now, the number of neutrons depends on 2. The mass number of the atom and the number of protons of the atom or the atomic number. We are simply going to subtract the number of protons from the mass number. So the mass number of boron is 6 minus The number of proton of boron is 5. So 6 minus 5 is 1. We simply subtract the number of proton from the mass number of the atom to get the number of neutron of the atom. Let us now try to determine the number of neutron in our nitrogen. So our nitrogen has a mass number of 14 minus the number of proton or atomic number of 7, we get 7 as the number of neutron for our nitrogen. So 14 minus 7, the answer is 7. Now it's your time to try to determine the number of neutron for magnesium, aluminum, silicon, and sulfur. So what do you think is the answer for magnesium? That's right. The correct answer is 12. How about for aluminum? Correct. The correct answer is 14. How about for silicon? Awesome. The correct answer is 14. And how about for sulfur? 16. Very good. So that is on how to determine the number of neutron in an atom. Let us proceed to determining the charge of the atom. Let us look at the charge of boron. The charge of boron is 0. After determining the charge of the atom, look at the number of proton of that atom and the number of electron of that atom. If the charge of that atom is 0, it means that the atom is in a neutral state, which means the atom has equal numbers of protons and electrons. So for boron, we have 5 number of protons and 5 number of electrons. That's why the charge of boron is 0. Also take note that proton is positively charged and electrons are negatively charged. Again, comparing the two, our boron has 5 protons and 5 electrons. So that means they have the same number of protons and electrons. That's why the charge of our atom is 0. So 0 is the correct answer. Now, let us try and determine the charge for our neon. Let's try and compare the number of protons. So we have 10 protons for neon and the number of electrons for neon, which is also 10. So our neon has 10 protons and 10 electrons. So they are equal, which means that it is in a neutral state. So it has also a 0 charge. Now try to determine the charge for magnesium. Again, look at the number of protons. So magnesium has 12 protons and the number of electrons. So magnesium has only 10 electrons. So our magnesium has more protons than electrons because it has 12 protons and only 10 electrons. 12 is more than 10. So 12 is the number of protons, so the charge of our atom must be positive. Then compare the number of proton and electron. The number of proton is greater by how much than the number of electrons? So 12 is greater than 10 by 2. Therefore, the charge of our magnesium is positive 2. What about the charge of silicon? That's right. The correct answer is 0 because the total number of proton of silicon is 14 and the total number of electron of silicon is also 14. So they are equal, which means that the atom is in a neutral state. So there is no charge or zero charge. So the correct answer is 0. So that is on how to determine the charge of the atom. You have actually finished and completed the table. Congratulations! You are now able to determine the number of protons, electrons, and the number of neutrons in any given atoms. You're also able to determine the charge, the element name, and the isotope of that particular atom. Always remember, knowledge is power. So, thank you! Maraming salamat mga mahal kong mag-aaral sa inyong ibayong pakikinig. Sana ay mayroon kayong karagdagang kaalaman na natutunan sa araw na ito. Again, learning is fun. Let us have fun as we venture together in the wonderful world of science. This has been your teacher, Teacher Melvin. Thanking you for watching. I hope to see you next time. Bye-bye!